So basically, this article introduced the J2 induced perturbation with the analysis of satellite motion. In the MATLAB, we have just orbital simulation, the orbital dynamics, and the simulate it's the orbital dynamics is basically a low Earth orbit, which is basically LEO, and the satellite using the MATLAB based orbital dynamic framework. And J2 means the oblateness, Earth's oblateness, perturbation to accurately capture the secular variations in the orbital elements. Okay, basically in the complete article we are focusing on the circulation of Earth according to its orbital in the orbital framework according to the gravitational force and how it demonstrates its astrodynamics, and how it demonstrates its to compute the satellite's trajectory over the extended mission durations. The simulation basically evaluates the effects of J2 on right accession of ascending node. Okay, we called it RAAN, and the argument of perigee and orbital precession as well, okay. And in the MATLAB results, we have just concluded the visualization of 3D orbit plots with the global ground tracks and enabling the detailed spatial interpretation of orbital motion, as well as we have just also added the model computational efficient approach for the orbit prediction, mission planning, as well as the preliminary satellite design. So here is I have just added with the abstract with the introduction, which provide us the accurate prediction of satellite motion of the fundamental in the modern space engineering. So here is the J2 uh, perturbation as well. Basically, so MATLAB effect offers a powerful environment to numerically simulate and provides a flexible tool for the solving nonlinear orbital differential equations according to the generation of 3D visualizations as well. Okay, so here is the background with the motivations of with the importance of J2 perturbations as well, RAAN accordingly, and modeling and numerical approach as well. In this table basically represents the numerical integration settings according to the parameters used in the simulation in MATLAB for the J2 purposes. Okay, these are the objectives with the expected outcomes, and in the objective basically we main objective is that we need to produce a publication quality visualization of 3D orbit ground track and the element time histories with the tabulated summaries, comparing the perturbed and unperturbed valuations as well. So here is a problem statement I have added with the mathematical approach. In the mathematical approach, I have just used the equations for example, differentiations of potential produces with the J2 acceleration vector. It also produces Earth's oblateness. We have used the gravitational potential to expanded spherical harmonics and truncated after the second zonal term. So here is the methodology which I have used the complete J2's perturbations in a low Earth orbit satellite basically. So Cozy was one of the scientists who mentioned to close the Earth satellite in different and different orbit determination, and Monteberg and the Gill also presented the satellite orbit determination using the MATLAB. Okay, so here is the design MATLAB simulation with the results and analysis. These are the parameters used in the MATLAB for with the uh, different angles with the initial eccentricity, inclination, and the RAAN in terms of resistance values. Okay, so here is the MATLAB output results, which is 3D orbit around the Earth, and this is the satellite ground track, which is basically projected on the global map, and here is the complete orbital elements evaluation according to the history of semi-major axis with the angle of perigee, true anomaly, a RAAN precision with the inclination. Okay, so yes, the results and discussion also added with the conclusion and references. Okay, so let me just provide you the clear output demonstration. These are the MATLAB functions which we have used for the compute specific angular momentum with the object of J2 with the row values with the RV2 coefficients as well. Okay, let me just run it. So here is the complete MATLAB code you just run. And just run. I'm really sorry for that. Okay, and you just run this MATLAB file and you will get the output results like this. Okay, a 3D orbit around Earth, ground track with the orbital elements valuation. Okay, when you will just maximize, you will get the more accurate values. Okay, so if you need to ask anything, you just ask me, I will answer your questions. Thank you.